In this video, we'll be talking about absolute value, order of operations, and evaluating expressions. The definition of absolute value is on your screen here. So it looks at the symbol like this. So when you see those two straight bars surrounding a number, then those are notations for what is the absolute value. So the absolute value is basically asking you a question. It's saying, what is the distance that number is from 0 on a number line? So for instance, if you were looking at the absolute value of 4, well, 4 is here, so that is 1, 2, 3, 4 steps away from 0. So the absolute value of 4 is 4. If I go to the other end of the number line and look at -4, well, -4 is still 1, 2, 3, 4 steps away from 0. So the absolute value of -4 is also 4. So it doesn't matter if it's a positive or a negative, it's just asking you how far is it from 0 on this number line. So if we're looking at how to apply these and you're looking at them in situations, so what we want to do is figure out, is the absolute value of -4 less than, greater than, or equal to 4? So the absolute value of -4, so -4 is how far away from 0? Well, that is 4 units, which means it's equal to 4. This other one is asking you, well, what is the absolute value of -6 versus, or comparing to, the absolute value of -16? So you first have to figure out, well, how far is -6 from 0? How far is -16 from 0? Which is 6 and 16. Then if I want to apply these symbols here, we're looking at less than. So this is less than, just to review. And this is greater than. So another way you could look at these, if getting the symbols is hard, so you're going to see these reoccur throughout other topics as well. But think of it as a mouth. Okay, and the mouth is always open to the bigger number. So because 16 is greater, I want the mouth open to 16. Okay, so then the absolute value of -6 is actually less than the absolute value of -16. So go ahead and pause the video and then try these on your own, and then you can hit play again and hear the answers. So go ahead and pause and you try. So the absolute value of -2.7, how far is that? So even though it's a decimal, it's still asking you the same question. So how far is -2.7 from 0? Well, that is just a positive 2.7. And then the absolute value of -2 is 2 units from 0. So then this one would be greater than. The absolute value of a positive 10 is 10. The absolute value of a -10 and 1/3. So sometimes we see this as positive and that's negative, and we think instantly that the positive is bigger, because if it didn't have the absolute value signs, it could, or it would be. This one here, so this is the absolute value of -10 and 1/3. Well, that is 10 and 1/3 steps away from 0, which actually makes that greater. Next, let's move into reviewing kind of this idea of exponents. So exponents is just repeated multiplication. So when you're looking at an exponent, you have a big number and you have a small number. Your big number is your base. Your small number is classified as your power. The whole thing together is looked at as an exponent. Okay, so your base, this big number, is what you're going to repeatedly multiply. So if I have 2 to the 4th power, this is saying I have 2 4 times. So this would be 2 times 2 times 2 times 2. To evaluate that out, you do the first 2. 2 times 2 is 4. Then you can do 4 times the third 2 there and get 8. And then do 8 times the last 2 and you get 16. Okay, so the big number is what you repeatedly multiply. The small number, the power, is just telling you how many of that big number you need. Okay, now we're going to skip to this last one here with the parentheses. Okay, so there is difference between this last one with parentheses and this one here without parentheses. So the one with parentheses I consider it's kind of like a big bear hug. Okay, so parentheses are holding something together. So it's saying this negative sign and this 2 have to stay together because the parentheses tell it that we have to. So when I look at this negative 2 is still my big number, and because it's in parentheses, I want to take this whole thing 4 times. So that would be negative 2 times negative 2 times negative 2 times negative 2. When you evaluate that out, you're still going to end up with a positive 16. Okay, and just because there's parentheses and there's a negative in it doesn't always necessarily mean that you're going to end up with a positive down here where you got the positive 16, but sometimes you do. So let's look at this middle one here and talk about why is this middle one different than the one with parentheses. Well, the key is that it doesn't have parentheses. So if I look at this one, I see negative 2 to the 4th power. Well, this is saying this negative isn't attached to the 2 because there's not parentheses holding it together. So when I go to evaluate this, the only thing I'm taking 4 times is the 2. But then what does that mean for this negative sign? Well, it just means that it stays out front until you evaluate everything else. So I can view this first 2 as a negative 2, or I could just say, well, 2 times 2 is 4. 4 times 2 is 8, and then I have 16. But then this negative has to get dropped down. So the answer to this middle one is a negative 16. So the last one, this third one with parentheses, got me a positive because of the parentheses. This middle one did not give me a positive because the negative is not being held together with the 2 by parentheses. Let's look at another one. So this one has fractions, but all the same concepts apply. So we'll look at this first one. I have 2/5 to the 3rd power. Notice it has parentheses around it, which is fine, but there's no negative or sign either inside or outside. So this is saying take everything inside those parentheses 3 times. So that's 2/5 times 2/5 times 2/5. And just to review, if you do multiplication of fractions by hand, or you're allowed to use a calculator, so you can just punch that into your calculator as well, but you just multiply straight across when you're multiplying fractions. So 2 times 2 is 4, 4 times 2 is 8, 5 times 5 is 25, 25 times 5 is 125. And that would be your answer for that first one. Okay, moving to the second one. Notice that there's still parentheses around this 2/5, but notice the negative is outside the parentheses. So that means when I'm looking at the power of 3, this 3 is telling me I just want everything inside these parentheses. So that means 2/5 is all I take 3 times. And then that negative, like the last slide, is just hanging out front. So that would still yield me 8 over 125 as the last one, but that negative stays out front. All right. And the last one, again, it still has parentheses, but now the negative is inside. So when I take 3, I want to take 3 of everything inside. So that negative 2/5, that negative carries over because of the parentheses. So when we're dealing with exponents, parentheses matter. So make sure you're thinking about that and you're identifying that if they have parentheses. So when I do this one, you're still going to end up with 8 over 125, but the sign, I have a negative times a negative is positive, and then I have, so negative times a negative is positive, and then that positive times this third negative takes me back to a negative. So for this one, for this instance, the second one with parentheses still gives me a negative, even like the second one who didn't have a parentheses. Okay, so go ahead and pause again and try these two. There's 2 questions here. And just determine what is parentheses negative 0.8 to the second power, and then what's negative 0.8 to the second power without parentheses. So you can do this by hand or you are allowed to use a calculator, but think about what we just learned in the last couple slides when you're applying these answers. So pause and try. So for this one, here we have parentheses, so that means everything in the parentheses has to go twice. Whereas this one, we don't have parentheses, so only the 0.8 goes twice. The negative stays out front. So this one should have yielded you a positive 0.64. This one would have yielded you a negative 0.64. Okay, again, the difference was this one had parentheses, the first one had parentheses, the second one did not. Okay, the order of operations. So here I gave you the steps of the order of operations. You can pause it and write it down if you want before I talk about it so you can get everything in your notes. But if you're using the guided notes, it'll help. So order of operations, some of us might remember this as PEMDAS. Okay, so you got please excuse my dear Aunt Sally, whatever is the fun little trick you learned it the first time. But basically what the P is saying is I have to do all grouping symbols or the parentheses first. The E represents the exponent. The M and the D represent multiplication, division, and then the A and the S represent addition and subtraction. So these last two, keep in mind of what it says. So we're doing multiplication or division in order from left to right. So in other words, multiplication and division are like a team, as are addition and subtraction. So when I'm looking at these orders, you're really only having 4 steps. When you get to step 3, you ask yourself, do I have multiplication or division? And if the answer is yes, you do whichever one comes first. Same thing when you get to step 4. Okay, and that'll show up in our examples here in these next few slides. Okay, so let's do some examples together. So we got a couple examples together, and then I'll allow you to pause and try some yourself. So for this first one, so again, I'll write, we got, please excuse my dear Aunt Sally, and these are teams. So do I have any parentheses in this first problem? No. So I move on. Do I have exponents? Yes, I do, and it's right here. So the first thing I'm going to do is say, well, 5 squared, or 5 to the second power, is 5 times 5, which is 25. Then I'm going to drop everything else down. A key for order of operations is make sure you do one thing at a time. When we start to try to do multiple things in the same step until we get more comfortable with it, we lose things and then we get confused and we get the wrong answer. So I took care of the exponents. Now I'm right here at MD. So do I have multiplication or division? Yes, I do. I actually just have division. So I do 6 divided by 3 and get 2. And then I can do the very last step of addition and get 27. This next example is a good example because I have 2 sets of grouping symbols. So the first thing I'm going to do is parentheses, but I have to start with the innermost parentheses first. So I'm going to come all the way in here and figure out 2 times 3 plus 1. So 2 times 3 is 6. Because I do multiplication before I do the addition based on the PEMDAS, and then 6 plus 1 is 7. So now let's drop everything else from the beginning down. So I had 1 plus 2 brackets 5. Then that's where my parentheses came in, minus 10 bracket. So I took this innermost parentheses and simplified it down all the way to a single number. Now I can focus on these second sets of grouping symbols, which are called brackets. So I have 5 times 7. So if I ever have something that looks like this and all that's between them is a set of parentheses, this here denotes multiplication. So I have 5 times 7 minus 10. Well, I do multiplication first based on PEMDAS, so that's 35 minus 10, which gives me 25. So I took the brackets, simplified it all the way down. Now I can go back up and drop down the 1, the plus, and the 2. So sometimes we jump ahead of ourselves and we think we have to do this 1 plus 2 first, but we don't, because order of operations tells me I always do multiplication and division before I do addition and subtraction. So I need to jump to the end here and do 2 times 25 to get 50. Then I can add the 1, which is 51. So that's a good example to have on hand. All right, these next two examples are still order of operations, but notice that they look like fractions. So I have all of this stuff on top, and then I have stuff on bottom. So the key here is to say, well, I need to figure out what is this top, and then figure out what is this bottom before I can worry about the fraction. So if I have 6 plus 9 divided by 3, again, order of operations tells me to do multiplication, division before addition or subtraction. So I have to do the 9 divided by 3 first, so that would be 6 plus 3. And then since it's an infraction, I could go ahead and do this exponent on bottom too and say, well, 3 squared is 3 2 times, which is 3 times 3, which is 9. So again, that's 3 times 3. All right, so it's not 3 times 2, it's not 6, it's 3 times 3. Now, I can finish out this top and say, well, 6 plus 3 is 9, and I have 9 on bottom. So when you're looking at a fraction is nothing more than a division problem. Fraction equals division. So when you're looking at this, you're saying, well, 9 divided by 9 is 1. And that would be your answer. Okay, the second example, again, I want to figure out what's the whole top, what's the whole bottom. The bottom's easy, so let's go ahead and fill that in. 8 minus 5, that's 3. Now the top's going to take us some work. So if I'm looking at the top, well, the first thing I have to do is parentheses. But I don't really have any parentheses. But I do have absolute value bars. So absolute value bars are going to serve in that exact same first step. So if you have the absolute value bars, we want to figure out all of that first. So if I do this, 7 minus 4, that gives me 3. So the absolute value of 3 is 3, because it is 3 units from 0. So that's going to be 1 plus now the 3, so this absolute value comes down to 3. I dropped the absolute value bars because I interpreted that there. And then I have plus 3 squared. So I have parentheses, did that. Now I do the exponent. So this 3 squared is 3 times 3 again, which is 9. So that's 1 plus 3 plus 9. And then the 3 on bottom is just hanging out until we can get to the end. So 1 plus 3 plus 9, well, 1 plus 9 is 10, so 10 plus 3, that would give me 13 for the top, and 3. So notice here, if I say, well, 13 divided by 3, well, that doesn't go into it evenly. So at this point, you could either write it as a decimal, so you could say that would be, what, 4.3 repeating? Or you could say that 3 goes into 13 4 times with 1 left over, and it's 4 1/3. or you could simply leave it as 13 over 3. So it just depends. Make sure you're just looking at seeing if it asks for a certain type of notation. But either one of these are all equivalent. Okay, it's your turn. So go ahead and pause. Give yourself plenty of time. Work through them. At least attempt all 3 before you hit play and hear my explanation of it out. So give yourself enough time to do all of that. Okay, so the first one will look like this. So when I go to do the exponent here, so I'll write your PEMDAS up top here. So when I go to do the exponent, it doesn't have parentheses, so then this is just 8 times 8 with the negative out front. So that would have yielded you a negative 64 minus the 7, and then that's going to give you what? A negative 71. All right? So make sure you pay attention to this. That might have been a reason if you got that incorrect. It doesn't have parentheses, so I don't take the negative with it when I repeat the 8. All right, let's look at the second one. 2. So I have 25 plus 2, bracket, negative 4, parentheses, 5 times negative 3 plus 7 minus 10, bracket. That's a long one. Okay, so let's start with our innermost parentheses first. So I have 5 times negative 3 plus 7. So that's going to be 5 times negative 3. I do multiplication before the addition. That's negative 15 plus 7, which is going to give me negative 8. So these innermost parentheses come down there. Now I'm going to drop everything else down. All right. Now let's focus on the second set of parentheses, the brackets. So I have negative 4 times negative 8 minus 10. So I do the multiplication first again. So negative 4 times negative 8, a negative times a negative is positive. 4 times 8 is 32. Minus the 10 gets me down to 22. Drop down the 25 plus 2. So again, just similar to the example we did together before, I have to jump and do the multiplication first because order of operations tells me to do that. So that would be 44. So I have 25 plus 44. And then that would give me 69. Okay. All right, and the last one looks like our fraction ones that we did. So I have negative 11 plus 9 divided by 3, absolute value 4 minus 2, all over negative 2 squared. Okay, so instead of working across, I'll work down on this one because of the space. So let's do the first step in the top. So I'm going to do this here first. So 4 minus 2 is 2. The absolute value of 2 is 2. So that top, your first step, should look like negative 11 plus 9 divided by 3. And then this absolute value of 4 minus 2 comes out to just be 2. The first step in the bottom, notice this has parentheses. Unlike the first one, it didn't. So because there's parentheses, I take everything inside the everything inside the parentheses twice. So this would be negative 2 times negative 2, which would give you a positive 4. So now the top, I have negative 11 plus 9 divided by 3 times 2. So order of operations tells me to do multiplication or division. Notice I have both. I have division here with 9 divided by 3, but then I have multiplication with the 3 times 2. So I do them in order from left to right. So some of us want to do 3 times 2 first to get 6, but that's not the way order of operations tells me to do things. So I actually need to do this first. So do negative 11. 9 divided by 3 is 3 times 2. And the 4 on bottom. So now I have negative 11 plus 6 over 4. Negative 11 plus 6 gives me a negative 5 over 4. So again, I could leave it as negative 5 over 4 because 4 is not going to go into 5 evenly. Or I could write that as negative 1 1/4. Or it could be negative 1.25. All of it is equivalent. This, and we'll get to reviewing fractions. So this is an improper, this is a mixed number, and then that's decimal. So the last objective in this video is looking at evaluating expressions. So before we get started, we'll just look at some definitions just so you understand when I say these words, what exactly it's looking at. So the first one is a variable. And a variable is any letter in the alphabet, and it's going to represent an unknown. So anytime we don't know something, we give it a letter, which means we give it a variable. An algebraic expression looks at a combination of numbers, variables, and operational symbols. So adding, subtracting, multiplying, dividing. But within an algebraic expression, you're going to have numbers and variables in the mix. So when I say we're going to look at evaluating the expression, ultimately we're going to look at, well, we're going to take this algebraic expression and we're going to replace the variable terms with a number, and the number will be given. And then once we replace variables with numbers, we go back to what we just did with the order of operations. So the only thing new we're adding here with this objective is we're first identifying an expression, and then we're substituting in numbers for the unknowns to use the order of operations to simplify them down. If you need time to pause and fill in, make sure you do that along the way. So we'll look at a few. So I gave you up here, so it says evaluate each expression when x equals 1 and y equals 4. So for all of these A through D, x will be 1, y will be 4. So if I look at this first one, A, 3y squared. Well, before I plug anything in for the variables, I like to say you might as well put parentheses around or in the space of that variable. So I always get the question, do you have to? No, not really. But sometimes you do have to. So if you can get in the habit of always putting parentheses around what you substitute in for, it's going to eliminate that fact of you knowing when you have to have them versus not having to have them. So y is 4. Y equals 4. So let's plug a 4 in there. So now I'm looking at 3 times 4 to the second power. Well, this is just utilizing the order of operations. So I do exponents first. So 4 times 4 is 16, and then times it by the 3. And that's going to give you, that's 1848. B has 2 times y, so y is 4, minus x, which is 1. So I do the multiplication first. 2 times 4 is 8, minus the 1 is 7. So once we get to this step, once we substitute in correctly, then you're looking at order of operations. C is 11 times x, which is 1, over 3 times y, which is 4. So this would give you 11 on top, 12 on bottom. D, I have x over y, so that's 1 over 4, plus 6 over y, which is 4. With fractions, when the denominator is the same, you just add the top. So 1 plus 6 is 7, and the denominator stays the same. Again, that can stay as 7/4, or it could go to 1 3/4, or 1.75. So here's a couple more examples, and then you'll get to the point where you can try. So mn divided by 6 plus 10. M is what? 7. N is what? -6 divided by 6 plus 10. So I'm going to run through these order of operations rather quickly since we just did them, but if you need the extra practice or review, you can always watch the video again. So 7 times -6 is -42 divided by 6 plus 10. Do the division, that's -7, and then add the 10, which would be 3. So again, all we're adding is this step here, the substitution step. So h is -2 plus g, which is 6, times g minus h, which is 6. Now watch what I do here. Minus h, so minus, but then h is also a -2. So I have to put 2 negative signs there. Okay, and I could put brackets around here so you see the difference. But if the expression calls for a subtraction, but then you're adding in a negative, make sure you have 2 there. So this is -2 plus 6, and then 6 minus a -2. 2 negatives right next to each other make a positive. So that's 6 plus 2, which is 8. And that would give me 48 for that multiplication that has to come before the addition, which gets me 46 in the end. Okay, so a few harder examples. So b is 1 minus 1 squared plus a squared. So when I do this, put parentheses, because in this case I'm going to need them. So 1 minus 1 is 0. -6 squared. Again, there's parentheses. There has to be parentheses. If you didn't put parentheses, you would get your answer wrong. This is -6 times -6, which is 36. 0 squared is 0, plus 36 is 36. All right, so be careful of this. Whenever you substitute in, we need to have parentheses. If you're substituting in a negative for an exponent, parentheses are very important because of what we talked about earlier with exponents. So this one we have y, which is -2, bracket, x, which is -4, minus, parentheses, 9 minus 4 times y, which is -2, bracket. So that could be kind of confusing there, but this all goes together. So we're going to do this innermost right here. We're going to do this first. So 4 times -2, or -4 times -2, gives you a positive 8, which is going to give you 17. So then you have -2, bracket, -4, minus, and then this whole parentheses here became 17. So now -4 minus 17 gives me a negative. So if I have -$4 and I spend 17 more, can't do that, you're further into debt. So that's going to be -21 and then times that by -2. So a negative times a negative is positive. 2 times 21 is 42. Another good example. So be careful with this trickiness when you have brackets and parentheses and then you substitute in a negative. Okay, so I gave you 3 examples to try on your own, so go ahead and do that. It kind of works from a little easier to harder, but again, give yourself plenty of time to kind of navigate through all 3 of these, and then we'll go over them. Okay, so the first one is y plus x. Nope, that's not it. Yx plus x minus y. So x is 7 and y is 3. So I have y times x. Y is 3, x is 7, plus x again, which is 7, minus y, which is 3. So I'm going to do the multiplication first. So it's 21 plus 7 minus 3. Now I do addition because it comes first. So that's 28 minus 3, which then gives me 25. Not too difficult. No negatives in that one. The next one is g parentheses h minus 9 to the 3rd power plus 2. All right, so g is -8, parentheses, h is 9, minus 9 to the 3rd power plus 2. So I do these parentheses first, so that's -8, 0. Do the exponent, that's still 0. Do the multiplication, which is 0. So you get 2. All right, and the last one, x parentheses y squared minus 3 squared. Okay, so x is -9, y is -4. So watch what I do here, okay? So I'm going to change this to a bracket because I now want to add parentheses of -4 squared. All right, so I'm going to do this exponent right here first. So because there's parentheses, there has to be parentheses. That's -4 times -4, which is a positive 16. So I'll go ahead and drop it down so you can see what it looks like. Now I'll do the 16 minus 3. So I have to do this whole entire thing here before I can worry about that exponent. So 16 minus 3 is 13. Now don't go doing -9 times 13 first. I have to then do this exponent. So this -9 times is just going to hang out. So 13 squared is 13 times 13, which would give you I got 169. Now I'll take that times it by 9. Now this is a negative times a positive, so I know my answer is going to be negative. Now I just need to figure out what 169 is times 9. 9 times 9 is 81. 9 times 6 is 54, plus 8 would be 62. 9 times 1 is 9. 9 plus 6 is 15. So I got 1,521. And that would be your answer. I was checking my work. Right, and that's the end of that. So we looked at absolute value, exponents, just the basis. We looked at order of operations, and then we looked at evaluating expressions. So a fairly long video, but a good review here in this first part.